Hello everyone, welcome to Math with Allison. Today we're going to be continuing our limit series. We're going to be talking about rational functions and what happens when the denominator is equal to 0 at the limit value. Specifically, we're going to be talking about factoring and canceling. So if you'd like to see my previous videos, they're linked here. We go over the basic rules, the definition of a limit, and also one-sided limits. So let's go ahead and dive into it. Here we have rational functions. This was talked about in my previous video if you'd like to look at it. But what happens if the denominator is equal to 0 at the limit value? So let's go ahead and take this first example here. I have the limit as x approaches 2 of this whole function. I also have the function graphed right here so we can see what happens. So let's just go ahead and look at the graph and take an educated guess on what we think it's going to be. So if I go to a value of positive 2 right here, looks like my function is right about here, which looks like it's about negative 1/2. If I approach it from either side, I'm going to be approaching that same value. So let's go ahead and look at our limit. If we look back at our basic rules, when we have a quotient of two polynomials, we're able to take those limits and take the limit of the top and the limit of the bottom. But it's provided that the denominator is not equal to 0. So let's go ahead and look at the denominator. Going ahead and just plugging it in to see what happens, I get 2 squared minus 4, which is indeed equal to 0. So we have an issue here. One way that we can go about solving rational functions is we can factor both the top and the bottom and see if our issue number cancels at all, if they divide out. So let's go ahead and try that. And we can see right here we have the same factor of x minus 2, which is our problem number, right? Because 2 minus 2 is equal to 0, and that gives us a denominator of 0. So let's continue using our limit rule. So now I can use the quotient rule, and I can go ahead and distribute that limit to both the top and the bottom. If you want to skip this step in your writing, you totally can. You can just go straight to this next step, which is these are both linear functions, and I can just plug in that value of 2. So I get 2 minus 4 over 2 plus 2, which is negative 2 over 4, which is indeed negative 1/2, which we can also see in that photo, right? So again, if you want to skip this part right here, you can go straight to this step right here. Notice that when I apply the limit, when I plug in x is equal to 2, I drop the limit notation. And that's because that is the action of the limit. I plug in 2 and then I plug in chug. So I simplify and get negative 1/2. And so this is what our limit is equal to. And originally, right, we weren't able to do this limit because the denominator is equal to 0. So this is a really great method of solving. Let's go ahead and go through more examples of this. I'm going to scroll down. Next, we have the limit as x approaches 4 of x squared minus 16 over 4 minus x. I provided us another graph of it. We can see that this turns into a linear function. So let's go ahead and try to factor this. Notice that these two terms, x minus 4 and 4 minus x, are super similar, but they don't divide out nicely. We actually need to factor a value from the denominator in order for those to be exactly the same. If I do that, I take the limit as x approaches 4, x plus 4, x minus 4 in the numerator. But what I'm going to do in the denominator is I'm going to pull out a negative 1. So I pull out a negative 1. That 4 becomes negative, and that x becomes positive. If I were to rewrite that, having the positive value come first, and now I can see that these values divide out. So now I'm left with, so we can apply quotient rule. I'm going to skip writing it all out, and I'm just going to plug it right in. So I get 4 plus 4 in the numerator divided by negative 1, which gives me negative 8. Let's go ahead and check with our beautiful drawing over here. I guess I didn't really show it. 4, this should go down to 8. Right about, if I continue this out, right about there. Negative 8. Artiste, draw good lines. So that is a great example of how factor and cancel can be kind of sneaky. If we were to just cancel those out originally, we wouldn't have gotten that negative value. We would have gotten positive 8. So make sure to pull out our negative values. Next, we have more of a abstract limit. We have the limit as x approaches negative b of this whole function over here. This one's a little different. We're going to factor it a little differently, but let's go ahead and look at the denominator and see what our issue is. I'm just going to go ahead and plug that in. I get 4 times negative b plus b, 4 times 0, which is equal to 0. So this is our issue, that x plus b in the denominator. So we're going to factor this a bit differently than we have the other problems. So we have the limit as x approaches negative b, and I'm just going to pull out an x plus b in the numerator. So x plus b, and then I have my leftovers, and now we're able to cancel these out, right? They divide out very nicely. I'm going to rewrite my limit. I'm going to use the quotient rule, right? I'm going to go ahead and apply the limit to the top and apply the limit to the bottom. I'm going to skip writing that step. Reminder, when you take the action of the limit by plugging in the limit value, you drop writing the limit. I'm not going to write it anymore. So now I get 0 to the power of 6 plus 0 to the power of 9 over 4. That's just going to give us a value of 0, and that's our limit value. Let's see another example. We have the limit as x approaches negative 1 of 2x minus 1 quantity squared minus 9 over x plus 1. So this one's also a bit different because we're not going to be factoring out the numerator first. We actually need a FOIL. So let's go ahead and simplify this out a little bit. I get the limit as x approaches negative 1. I'm going to go ahead and FOIL out this guy. So I get, let's go ahead and simplify the top a little bit. Limit as x approaches negative 1. I'm going to try to make this look a little nicer, and I'm just going to go ahead and pull out a positive 4 from the numerator, so I get x squared minus x minus 2. I try to make the number in front of the x squared equal to 1 as much as possible, because I just think it's nicer for myself. And now I'm going to go ahead and factor out the numerator. So I get what? X minus 2, x plus 1. Yeah, typically what you're going to see is the denominator cancels, which means that x plus 1 has to be a factor. If that's not the case, then factor and cancel might not be the method to use. So we get that the x plus 1 divides out, which was our issue, right? Because negative 1 plus 1 is equal to 0. I'm going to go ahead and rewrite my limit. I have a linear function. I'm just going to go ahead and plug it in. So I get 4 times negative 1 minus 2, 4 times negative 3, which is equal to negative 12. Let's go ahead and view one more example. This one's, actually, these are one of my favorites. They're very tricky. So looking at our denominator, if we were to plug in a, we would get the square root of a minus the square root of a, which is equal to 0. So that's our issue again, right? The denominator is equal to 0. So the trick here is actually we can factor the top. Let's go ahead and do that. The limit as x approaches a, this turns into the square root of x minus the square root of a times the square root of x plus the square root of a. This is actually a difference of squares, and I'll show us how. You can think of this as the square root of x squared minus the square root of a squared, which is very tricky. It's a very sneaky thing, but I think once we've seen it once, we can keep that in our brain and apply them to future problems. But when you see that square root of x minus the square root of a in the denominator, that's a bit of a hint that that's going to be one of the factors. So we get that this factor, they divide out. I'm going to go write it down here. Now I'm going to go ahead and just plug it in. So I get the square root of a plus the square root of a, which is equal to 2 square root of a. But that's all I have for us today on factoring and canceling. This is one method of looking at solving limits when the denominator is equal to 0. We're going to go over some more methods in the future videos, so make sure to stay tuned. Leave a like if you enjoyed this video. Leave a comment of other topics or problems you'd like to see done. Thanks for watching.